Hopefully I didn't scratch a table there, but I figure for a hardware meetup, we should have actual stuff we can play with. So after we're done with all the presentations, feel free to come check out this stuff. Everything I'm going to show here has to do with Guerilla Prototyping in some way, which is not Gorilla the Great Ape, despite what DALL-E thinks. Turns out AI isn't as smart as it thinks it is. Really cool to see everybody in the crowd tonight. See some familiar faces out there and some I don't know. I think there's huge potential here in southeastern PA, and I definitely want to thank Informal and NextFab for hosting us tonight and getting this group together, and can't wait to see what happens in the future. As we go through this presentation, I'm going to do a really quick background on who I am for the folks who don't know me, so that you can see I'm not just a completely random guy off the street. I know a little bit about prototyping. Then I'm going to go into what my definition of guerrilla prototyping is. We're going to do some examples, and I'm going to pull out some real-world stuff from my history running engineering departments, pull out some more prototypes, and go from there.
The arrow?
There we go. Who am I? So my name's Tom, local guy, grew up in Delco, went to Drexel, studied engineering. Now I live in Chester County with my wonderful family. And my favorite cheesesteak is from Ishkabibbles. Sorry if those are fighting words. And what have I done? I ask myself this every day. I'm sorry to get existential. Coming out of school, I worked in medical device for a couple of years. Went into OEM electronics, focusing on currency validation. Landed a dream job, actually 2 dream jobs, at a couple of the leading marine component manufacturers in the country. And then about 2 years ago, pulled together a super awesome team, and we founded Epoch Boats. So my entire career has been R&D, new product development of electromechanical devices, big focus on taking stuff from whiteboard to prototype to commercialization. And as a result of that, I've found that we've got some problems with prototyping just across the board. And probably everybody in this room, if you've ever worked or built a prototype in your garage or maybe here at NextFab on one of the benches, you've encountered the problems with prototypes. You're probably a guerrilla prototyper, and you know some of these issues inherently. If you go into prototyping without a great plan, they multiply. I don't know if there's any Star Trek fans, but like tribbles, they tend to create trouble. And I like to frame it in the context of the unattainable triangle, right? So you have 3 options, you get to pick 2. If you want a prototype quickly with low time and high quality, it's going to cost you a lot of money. You don't get the 3rd. I would actually argue that from a prototype context, we don't get any of these, right? We know when we're building a prototype, it's usually going to be a sub-assembly, maybe a subsystem. It's not going to have the full functionality of the final product. So quality's out, right? If you don't have full functionality, that doesn't meet it. And time and cost are interrelated here. Anytime we build something, we've got to do design work, we've got to do setup time, we've got to do quoting, manufacturing, shipping, assembly, testing. When you add it all up, a single prototype spin can take weeks to months. And because of all the labor that goes into that, costs are often through the roof. How do we solve these problems? Guerrilla prototyping. Like I said before, a lot of you have probably done this. If you've ever felt like Tony Stark in that cave, building something out of a box of scraps, that's guerrilla prototyping. It's like no code for hardware. You don't need to know Python and React and JavaScript and HTML and C++ if you've got no code tools. In the hardware realm, you don't need to know about inverters and battery technology and creating battery packs if you can take an existing device and use the pre-engineered products from that to build your prototypes. I like the Iron Man example because it's exactly what guerrilla prototyping is. He's in this cave. He's got pre-existing equipment, ordnance, missiles and stuff. That by itself doesn't help him. A man can't pick up a missile and throw it, but he takes it apart and builds it into something that works for his situation. And that's what guerrilla prototyping is all about. To add context here, it's really this Mark I thing right there, which is guerrilla prototyping, right? It's like the early iPod prototype there. It doesn't have all the fancy features. It doesn't have the AI. It doesn't have the cool paint job. So that's really what we're focused on. Obviously, a product needs to go through all these to get to our iPhone 14, which everyone loves. But in the early days, the things that we can do to shortcut that process to get to something that proves proof of concept, proves functionality, is absolutely critical in moving projects quickly and maintaining costs. So I was thinking about a hypothetical. If I was going to make a product from scratch and kind of give an example of how a Guerilla prototype might come together. I said I live in Chester County. We got a lot of grass out there, and it never stops growing. Mowing the lawn is one of my most hated activities that I have to do. My wife makes me do it all the time. And when I think about it, I think, man, it grows all the time. I got to go to the gas station and get gas. I'm out there, it's sweaty, it's gross. I should just make a startup. I'm going to call it Mowgli, and it's going to be about autonomous lawnmowers. How do I solve these problems? We make a GPS lawnmower. We make it electric, self-charging. We can do all these cool things and have a concept that solves customer issues. But the more I think about it, there's a lot I don't know. How do you even make a lawnmower blade? What is a lawnmower blade made out of? I assume it's carbon steel. Is it improved plow steel? Is it a different grade? I don't know these answers. And if I was going to find these answers, this is a months and months long research project with testing and really expensive development. But if we do Guerilla prototyping, we can actually do it pretty quickly. We take pre-existing things. We can go buy a lawnmower. Amazon will ship it to my house in 24 hours. We can go buy a drivetrain. It's already got battery packs in it. It's got motors. And because of some of the great tools that we have with DIY drones, we can actually just buy a sensor kit with GPS and with controls so that we can do waypoint finding and make it a truly autonomous system. And this is what enables us today, with the infrastructure we have in place, to build something in days and weeks instead of months or years when we want to just prove out a proof of concept. So it all sounds good. Who does it apply to? Obviously, scrappy startups. And when we think about the term scrappy, that's like the politically correct way of saying broke. Scrappy startups don't have a choice. They're in garages, they're in places like NextFab, and they need to find ways to build stuff quickly, efficiently, and cost effectively. There's actually a lot of established companies that fall under this umbrella. I know because I worked for some of them. These are companies that might do billions of dollars a year in revenue, but when engineering wants to go build something or buy a new piece of equipment, suddenly the checkbook closes. And a lot of the examples I'm about to show have come out of this established company that really doesn't want to invest in R&D. This makes sense. These guys have no choice. I would argue that the more well-funded entrants in the market, like well-funded startups and established companies, also benefit from Guerilla prototyping. One of the really cool things is that if you take somebody else's product and build it into something, you develop an understanding of that technology and the shortcuts and the tricks that they put into it on a level that you can't get just from a comparative teardown, just from comparative testing. So what does this look like in the real world? When I was in currency validation, we had a project called SCR. This is what it is. It basically takes your dollar bill and says, is this counterfeit or is this real? And if it's real, we're going to put money into a slot machine or a vending machine, and we're going to let the customer buy what they want to buy. If you can't tell, it's pretty complicated. This particular unit had about 400 unique components that our engineering team had to design from scratch, and about 600 total components in the assembly. By the time we made production grade, production intent prototypes, we had over a month-long spin from commissioning a prototype to having it on the test bench for testing, and they cost about $5,000 a piece. In the context of a project that needs to be delivered in 1 to 2 years, that's not really a viable thing to develop under. So what we did day one with this prototype, we made a parallel plate model. For about $500, we got some laser cut plates, and we basically put in holes for all the gear centers and shaft centers where we thought, and we populated them with gears and shafts, and we actually, day one, were manually turning the drums to put dollar bills on there and make sure that we could hit all of our product specs with the geometry we had. It didn't work, but thankfully we didn't spend a lot of money, and it took us about 3 days to get a prototype. So we went in and we were able to make changes and iterate rapidly. And we continued to do that. We added in motors from hair dryers, we added in Arduinos, we understood what we had to do with PID loops, so that by the time we actually got to a prototype phase where we were spending $5,000, we were able to minimize the amount of churn and the number of prototypes that we did. Oops, just so I happen to have one here. Nobody can break it, thankfully, but you guys can come take a look, see some of the complexity there. Another project that I ran right at the start of COVID, it's called PTX. This is basically like a sunroof for a boat. And the idea is it automatically can extend or retract at the push of a button. So when it's retracted, you want to go fishing, it doesn't get in the way of your fishing rod, you have a good time. If you're at a sandbar and it's getting too hot, you push a button, it comes out, and you get shade. We looked at the incumbent on the market when this product came out, and we said, they're charging about $4,000 per product to put it on a boat. We estimated their BOM to be somewhere around $3,000 and looked at it and said, we can do way better, but we need to prove some assumptions before we do that. So we built a prototype right there. We used Guerilla methods. You can see it's by a pool, because it was in one of our team members' backyard, because it was when we were in lockdown. But we built this prototype for about $600. It was 2 off-the-shelf actuators from Amazon, some canvas that we bought a grommet kit on, and we installed the grommets, and we actually have shower curtain hooks that we're using to connect that canvas to the outside extension rods. We were able to pull this all together in about a week and learn a lot of really pertinent information about how that product had to work and some of the nuances of it without going through a huge multi-week engineering salary design spin. And ultimately we got it in the market, and the customers love it. So recently, I told you I started this company called Epoch. We design battery electric boats, and they're all made out of aluminum, welded aluminum. So we are definitely in the scrappy realm as far as startups are concerned. And as we were doing our initial prototypes, we realized that we need to take this aluminum and we need to cut it into profiles and weld it into our boat. If you look at this image up here, those are a grid of 5x2 sheets of aluminum, and each sheet is 8 feet long and 4 feet wide. So it's a lot of material, and we've got some complex curvature there. It's actually pretty difficult to convert that flat sheet into that complex curvature. But by the time I started Epoch, I've been doing engineering for a while, and I thought, we can do this easy. All I need is a roll-fed laser cutter. We'll put a big sheet of aluminum on there, and it'll come out really, really simple. It turns out we didn't have about $500,000 sitting in the bank, and we didn't have 36 weeks to wait for the lead time on that. So that was right out of the question. So we came down to earth a little bit and said, all right, well, we can do a CNC plasma cutter. This is in the tens of thousands of dollar range. You can max out some credit cards and do that. And it would work. But this was another one where, particularly at the time, we had a really long lead time on that. And there's a lot of ancillary costs that come with it, with facilities to put it in and people to run it. So that came out. We thought, how do we be really scrappy here? And someone had the idea of, well, what if we just were able to really draw those on with high fidelity, draw the shapes on, and manually cut them? And it was a pretty decent idea. And we started looking at equipment that we could use to do that. Relatively inexpensive, a couple $1,000s, still had a lead time issue. But as we were talking about it and thinking about making the purchase, we said, we've gotten super scrappy here. What if we just went to the next level? What if we took that off the table and said, how can we do it so cheap that nobody would believe it? And we figured out a method that we could do in about 2 days. We went to Harbor Freight. We bought a really cheap handheld plasma torch. And I went into my kids' playroom and grabbed this projector that we had sitting there. And we actually projected our engineering prints onto these 8x4 sheets at scale. And then we just took a Sharpie and we put all the complex curvature on there, and we went in and cut it, and next thing you know, we had a boat. So this is a lot of what we do at Epoch. We're doing a lot of hand stuff. We're using off-the-shelf electric actuators, 80/20, great tool of the trade. We're taking apart electronics from drones and from other equipment so that we don't need to go and do the really deep dive of how do you program something for GPS, or how do you program an accelerometer? Because when there's kits that already have that done, it just saves us time, and we're able to leverage the mass production of all these pieces of equipment. So most of you are probably used to this. We got DigiKey, McMaster Car. I see a bunch of catalogs around here. These are really the tools of how you do guerrilla prototyping. I don't want to belabor this point, but I do want to thank everybody for listening to my speech, and this is one of our prototype boats here in action. So you can do really cool things with these methods. Thanks.
prototype boats did you make with that method?
One so far, and the second one's in process.
About how long does it take to fabricate?
That first boat, it took us about a month in total. A lot of late nights in a very cold garage in January. The next one is probably going to take about half the time, just because we were innovating on the job for that particular build. Yep.
I'm listening to your talk, and it occurs to me that the way you think is substantially different than most people think. And so you kind of think paradigmatically and structurally about, conceptually about, for instance, the boat, about 3 or 4 different ways of thinking about how getting metal parts precise enough to actually weld. You go through all the, you started off with the industrial way, and then you keep getting less industrial, and you get more creative in your mind. So if someone's to be a guerrilla designer, you have to have this inbuilt willingness to experiment in your mind on these different paradigms. That's an essential skill to doing this kind of design work. So how do you nurture that within yourself, or find someone that thinks this way? Because I'm almost 60 years old, I'm an engineer, I design and build things, and it's uncommon, particularly for engineers, to think wildly like this about how to solve these problems.
Great question. So for anyone who couldn't hear, the question was, how do you take this concept, and I'm going to jump back a couple slides to the particular slide where this was, how do you take this concept and think about product development in terms of going from this hyper-industrial and try to be as creative as you can all the way down to something that's easily accessible? What I would say, I wish I could answer that concisely and bottle it and sell it, because I'd probably just shutter this startup and go be like a Zuckerberg billionaire or something. It's come from years of having to do it. And I mentioned I worked for some of those big companies that were scrappy as far as engineering was concerned. And that was just kind of even though it wasn't by choice, it was the lifestyle I had to live as a development engineer. And necessity is the mother of invention, right? So what I would say is, if somebody came to me today and said, hey, we love your startup, we're going to write you a super giant check, I probably wouldn't go to this level, right? I probably would have bought at least the CNC plasma cutter table, if not the roll form. But that's kind of how it goes. I think there's a great resource too in YouTube. There's a lot of really cool people who are doing interesting stuff like this and doing a lot of Hacker Lab stuff, and they're putting it out there and they're showing it. So I'm not a huge YouTube binger, but occasionally I come across some cool videos, and I just try to bookmark those and use them as inspiration as well.
I have a question, more of a comment, but the 2-axis chart you had about well-funded startups versus scrappy ones, I thought it was very funny. The companies you chose to put in the bottom right corner there, just very, very nice.
Yeah, I happened to watch the Dropout, which is about Theranos, a couple weeks ago, and yeah, it still grinds my gears. I will say, related to the well-funded startup comment is, and the previous question, we had ideas when we launched Epoch about what the technology was going to look like and how we were going to develop it. And if we had a blank check on day one, we would have gone down a certain path that I think would have worked, but it wasn't as good as what we've designed today, because we were forced into this path of being really scrappy and being really close to the technology. So, every time we touch a prototype, we learn something new. Every time we talk to a customer, we learn something new. And I do think sometimes funding can be a detriment to that, because it's so much easier just to say, listen, time is money, we got to go as fast as we can, and as long as the bank account is flowing, we're going to just move forward. So, yes? is there any company I admire that intentionally does low-cost, scrappy prototypes? I don't, because most companies really keep this stuff tight to the chest, right? Particularly big companies. So you only know about it from hushed alleyway conversations with other engineers and developers. So yeah, I wish I knew of more. I guess Epoch is the first that's like publicly coming out with it. Although there are certainly others that do some building in public and share it, but I'm not super familiar with many others.
You may have answered this, but the design for the boat, or what kind of is driving the design of the boat, is that something that you came up with that you're trying to get into the market, or is it driven by customer demand or a gap that you saw that you've been working with customers to push that forward?
Yeah, so initially it was because my co-founders and I had been in the boating industry for combined a couple of decades, and we saw a gap in the market. There's a somewhat famous quote of the 2 best days in a boat owner's life are the day they buy their boat and the day they sell it. And like everybody says it and they laugh about it at the marina, and then it's like when you think about it, you go, that's a really messed up thing to say. So we dove into that, and the average boat spends more time at the mechanic than it does on the water. And that's not a lie, that's real. And when we tried to figure out why that was, it just kept coming back to gas-powered, fossil fuel-powered engines, right? You're in a marine environment, you're sucking really damp air into the intakes, and it's bad for the engine. So that was where we started. We came up with an idea, we developed a prototype around it, we talked to a bunch of customers, and that idea still holds, but what we found were some other interesting things from our customers where we've kind of pivoted our product a little bit. But our main focus, and it's really resonating with our customers, is when you build a boat for a gas engine, there is a set of constraints and criteria you have to have, right? Everything wants to be close to the propeller, the power head, the fuel system, so the back of the boat gets really heavy. When you build it for electric, we can put the batteries anywhere and just do some more copper in the boat. And so we can do really innovative things with center of gravity, buoyancy of the boat, and increasing hull efficiency as a result of that. So we've actually designed the boats to the point where if you put a gas-powered engine on our boat, it wouldn't work right. And similarly, if you just take a standard boat like a Boston Whaler and put an electric motor on the back, it'll work, but it won't be as efficient as it could be. So it started as our own kind of idea, but then we tested a lot of our assumptions with live prototype testing and also customer interviews.
Do you have any insight on like scrappy testing? Because obviously once you've created a prototype, you validate it and do the thing you want it to do once, but then you need to establish some measure of reliability or repeatability, and sometimes those efforts can get expensive, specialized fixtures to accomplish. Insight there?
Yep, so the question is any insight about scrappy testing, low-cost testing, and yeah, I mean, one of the great things about testing, particularly in the prototype phase, before we get to like pilot runs and production runs, is usually those tests are limited in their scope. So using 3D printed jigs and fixtures and brackets, using accelerometers and Arduinos are actually things that can really play into early stage testing to keep the costs low. When you get into later stages and you actually need to have like validation that gets submitted to governing bodies, you usually need to have NIST certified load cells and stuff like that. But in the early days, a lot of that equipment, with piezoelectric sensors and stuff, can be done with really inexpensive parts from DigiKey, pulling some software off GitHub repositories and hacking something together with like a $20 Arduino. Yes?
More of a comment, just to expand on that, we found a lot that if you have a good understanding of the question you're trying to answer or the risk you're trying to mitigate, you can design a test or a prototype specifically to answer that question. So it might not look anything like a boat, and as a result, you can build it faster, smaller, and cheaper, and really just focus on a specific risk or question.
Great point.
I have a question. What's this?
So I did cut my presentation. I had like 200 slides, and I figured I would save you all the grief of that. But this in particular is what we call shallow water anchor. So this product, they sell for about $2,000 on the market, and we looked at it and said, man, that is a really simple thing that they're charging a lot of money for. So when you guys come up, if you want to take a closer look, we actually, the main components of this are just some angle that we bought off McMaster, and we cut with a chop saw, and we drilled some holes in it, and the actual rotating body down there was a pre-existing product that we took apart, and we were able to build this thing in less than a week. And part of the reason I brought it today is because I still use it on my boat. So it's a prototype that we did Guerilla style, and it's like 3 years old now and still works perfectly. Yes?
I just got a quick question about the boat design. What's the runtime you're expecting on that thing?
That's the million-dollar question. So the true answer is that it's impossible to give an exact figure, because we look at conditions, which way the wind blowing, which way the current's going, how much weight is in the boat, and they all have huge factors on that. And we also have battery options of, you can have the least expensive, smallest battery pack or extended range packs. But generally what we see in prototype testing is we'll go out on the water for about 4 hours of heavy duty testing where we're going high speed. We're really trying to, do stupid things with the boat. I guess we're not trying, we're actually doing. And usually at the end of those tests, we have about 50% of our lowest grade battery pack left. So what we see in the market is electric can service about 70% of the US Marine market overnight with existing technology and some clever efficiency gains on the boat design. And then the other 30% is like the guys who go 100 miles out to the canyon to go tuna fishing. We would need a step change in battery technology to be able to service those customers.
How do you charge batteries?
So just like charging an EV, we've got, it is an EV boat, so there are level 1 charging options, level 2 charging options, DC fast charging options. We are focused on boats that are trailerable, boats that live at people's houses. And
Talk to us after you're done.
absolutely.
Tom, what batteries should we use?
It's all lithium-based chemistries right now. We are not developing the batteries in-house, so we're relying on third-party suppliers for that. And thankfully, our suppliers have experience. They've been servicing the marine industry for a while.
All right, well,
We got one more.
one last question, then we're going to move on.
So, do you think that guerrilla prototyping, when you actually get to the manufacturing stage, can you identify like a specific lesson that you learned at some point in guerrilla prototyping that resulted in some kind of aha moment when it actually came time to scale?
Sure. So particularly on this product, the SCR, when we were doing the parallel plate prototypes on this, we started hand feeding notes, and we had a spec that each drum had to have $60 on it. That was our capacity. So when we hand fed, we could get $60 with like a millimeter gap spacing. And then we got some hair dryer motors, and we hooked them up to the drums, and we tried to hybrid feed notes, and we got like 5 notes per drum, right? Because you got a spool up time, and then the motor has inertia. So we went to the next level and said, let's put some sensors on here. We're going to do some light pipes. We got a little Arduino, and then we fed it that in a more automated fashion, and we got like 15 notes per drum. And that showed us really quickly early on that, hey, we've got some serious like PID things that we need to work out. We've got to do some look-ahead programming. And this was at a big company, not a startup. We had a mechanical team, a hardware team, and a software team. And usually the way we operated was like mechanical did their thing, hardware did their thing, and like a month before we had to ship the product, software would finally get prototypes, and they'd be working 24 hours a day to try and make it work. This was an instance where, because we did it this method, software got to get involved like 6 months before they normally would, and they got to start playing around with their algorithms and figuring out what the inertia of the system was. And they were able to build the software in such a way that they just had tunable parameters. So when we went to the next level and we did production grade prototypes, which is what we have here, and then ultimately off-tool pilot models, they could just go in and they could adjust basically gain values to impact the speed of the motors. And the system worked great. So
So just to say, you parameterize the solution according to the critical variables and then get ahead of time, build a software architecture that will support that type of software engineering.
absolutely. And these were variables that we probably should have known were something we'd be thinking about. But by having such an early prototype, it like smacked us in the face. And then we got to go make mistakes on like really simple things that we should have never, rookie mistakes, because that's what always happens, right?
Okay, well, thank you so much, Tom Ward.
Thank you.